The drill bit screamed through the ice, 3 kilometers down and still descending. Dr. Sarah Chen gripped the control panel, her knuckles white against the cold metal. The temperature gauge flickered, minus 73 degrees Celsius. Outside the research station, the Antarctic wind howled like something alive, something furious at being disturbed after millions of years of silence. "We're through," her colleagues shouted over the machinery's roar. "We've reached the lake." Sarah's heart hammered against her ribs. Lake Vostok, 4 kilometers beneath the ice, untouched for 20 million years, and they had just punctured its ceiling. The screen before her flickered to life, showing grainy footage from the submersible camera descending into the darkness. The water was impossibly clear, impossibly ancient, and then something moved in the frame, something that shouldn't exist. "What the hell is that?" whispered Dr. Marcus Webb, his breath fogging in the frigid air of the drilling station. Sarah leaned closer, her pulse racing. The shape darted past the camera again, too fast to identify, too deliberate to be debris. This was supposed to be a dead lake, a frozen tomb of geological history, but the movement suggested otherwise. It suggested life where life had no business existing. "Pull it up," she commanded, her voice tight with a mixture of fear and exhilaration. "Pull it up now." But before anyone could react, the screen went black. The camera line went slack. And in that moment, Sarah Chen realized that Antarctica had been keeping secrets far deeper than anyone had imagined. This is a continent that doesn't want to be known, a landmass that has spent millions of years hiding its mysteries beneath sheets of ice so thick, so vast, that they hold 60% of all the fresh water on Earth. If that ice melted, global sea levels would rise 200 feet, swallowing coastal cities whole, redrawing every map, ending civilization as we know it. But the ice isn't melting fast enough to reveal Antarctica's secrets willingly. Humanity has to dig for them, drill for them, risk everything to glimpse what lies beneath. And what lies beneath defies everything we thought we knew. Antarctica is the 5th largest continent on Earth, nearly twice the size of Australia. Yet it remains the most alien landscape on the planet. 97% of its surface is covered by ice sheets that can reach 5 kilometers thick in places. That's taller than most mountains. The weight of this ice is so immense that it actually depresses the bedrock beneath it, pushing the continental crust down into the mantle. Remove the ice and Antarctica would slowly rise, rebounding over thousands of years like a bruise healing in reverse. The temperatures here are incomprehensible to anyone who hasn't experienced them. The coldest temperature ever recorded on Earth was at Soviet Vostok Station, minus 89.2 degrees Celsius. At that temperature, exposed skin freezes in seconds. Breath crystallizes before it can leave your lungs. Metal becomes brittle and shatters like glass. The air itself seems to have weight, pressing down on everything, making each breath a conscious effort. For 6 months of the year, the sun never sets, circling the horizon in an endless twilight that drives some researchers to madness. Then for the next 6 months, darkness falls like a shroud, broken only by the aurora australis, those ghostly curtains of light that dance across the sky like the spirits of ancient explorers who never made it home. There are no time zones here because time itself seems meaningless in a place where the normal rhythms of day and night have been suspended. No one owns Antarctica. The Antarctic Treaty of 1959 established it as a scientific preserve, a continent dedicated to peace and research, claimed by no nation and shared by all. But this legal framework only adds to the mystery. What is being protected? What is being studied? And more importantly, what is being discovered that the public never hears about? Dr. James Morrison had spent 3 winters at McMurdo Station, America's largest Antarctic research facility. He had seen things that shook his scientific training to its core. On a video call with his daughter back in Seattle, his face gaunt from months of isolation, he tried to explain the inexplicable. "You have to understand, sweetie," he said, his voice crackling through the satellite connection. "This place isn't like anywhere else on Earth. We're finding things down here that don't make sense, things that shouldn't exist." His daughter, a journalism student, leaned into her webcam. "Like what, Dad? What are you finding?" James glanced over his shoulder, even though he was alone in his quarters. "Fossils," he whispered. but not the kind you'd expect. We found remains of an animal last month, dated to 25 million years ago. It had fur, it had teeth like a cat, but it laid eggs. Eggs. Sarah, mammals don't lay eggs, except for two species, the platypus and echidna, and this thing wasn't related to either of them. Maybe it's a new species of monotrim? That's what we thought at first. But the bone structure is all wrong. It's like evolution took a completely different path here, created something that shouldn't exist according to everything we know about mammalian development. He rubbed his eyes, exhausted. And that's not even the strangest thing we found. The conversation hung heavy with unspoken implications. Antarctica was supposed to be a frozen wasteland, a place where life had been extinguished millions of years ago when the continent drifted south and ice consumed everything. But the evidence suggested otherwise. The evidence suggested that Antarctica had stories to tell, stories that would rewrite textbooks and challenge fundamental assumptions about life on Earth. To understand Antarctica's mysteries, you have to understand its past. 200 million years ago, this frozen continent was part of Gondwana, a massive supercontinent that included South America, Africa, India, Australia, and Antarctica. Back then, Antarctica sat much farther north, its climate warm and humid, its landscape covered in dense forests of conifers and ferns. Dinosaurs roamed its valleys, amphibians bred in its rivers. Life flourished in abundance. Then, through the slow dance of plate tectonics, Gondwana began to break apart. Continents drifted on their separate journeys, and Antarctica slid south, crossing climate zones until it reached the bottom of the world. The forests died, the rivers froze, snow began to fall and never stopped falling, accumulating year after year, century after century, millennium after millennium, until the entire continent was buried under ice so thick that it created its own weather systems. But the ice didn't erase what came before. It preserved it, perfectly. Dr. Elena Volkov stood at the edge of Taylor Glacier, staring at the blood-red waterfall cascading down the ice face. Blood Falls, they called it, and the name was appropriate. The water looked like something had been slaughtered up on the glacier, the red liquid stark against the pristine white ice. But this wasn't blood. It was something far more extraordinary. "It's the iron," she explained to the documentary crew filming her, her Russian accent thick with excitement. "The water comes from a subglacial lake that's been sealed off for 2 million years. There's no oxygen down there, no sunlight, nothing that should support life. But there are bacteria in this water that have evolved to survive by metabolizing iron and sulfur. When the water hits the air, the iron oxidizes, turns red like rust, like blood." The cameraman zoomed in on the crimson cascade. "But how can anything live down there without oxygen or light?" Elena smiled, her weathered face creasing with the expression. "That's the beautiful question, isn't it? These organisms are chemotrophs. They don't need photosynthesis. They don't need organic matter. They survive on chemical reactions alone, breaking down minerals to extract energy. It's a completely different form of life than what we're used to, and it means that life can exist in places we never thought possible." She paused, her smile fading into something more profound. "It means life could exist on Europa, on Enceladus, on Mars beneath the ice caps. If it can exist here, in the most hostile environment on Earth, it can exist anywhere." The implications rippled outward like cracks in ice. Antarctica wasn't just teaching scientists about Earth's past. It was teaching them about the possibility of life throughout the universe. Every discovery expanded the boundaries of what was possible, what was plausible, what was waiting to be found. And the discoveries kept coming, each one more bewildering than the last. Over 45,000 meteorites have been recovered from Antarctica, more than any other place on Earth. The ice preserves them perfectly, the dark rocks standing out against the white background like puzzle pieces scattered across a blank canvas. But these aren't just any meteorites. Some of them come from Mars. Dr. Richard Armstrong held one such meteorite in his gloved hands, turning it slowly under the laboratory lights. It was surprisingly heavy for its size, about as big as a potato, its surface pocked and scarred from its violent journey through space. This rock had been blasted off the surface of Mars by an asteroid impact millions of years ago, had tumbled through the solar system for eons and had finally fallen to Earth, landing in Antarctica where it waited in frozen suspension until Armstrong's team found it. "Look at this," he said to his research assistant, pointing to a microscopic section on his computer screen. The image showed tubular structures, tiny filaments that looked disturbingly organic. These formations are consistent with fossilized bacteria, consistent but not conclusive. The debate's been raging for decades about whether this is actual evidence of Martian life or just mineral formations that happen to look biological. His assistant, a young woman named Keiko Tanaka, leaned in closer. "What do you think?" Armstrong was quiet for a long moment, his expression troubled. "I think we're not alone," he finally said. "I think life is common in the universe, not rare. I think Mars had life once, maybe still has life underground, in aquifers beneath the surface, and I think Antarctica is giving us a preview of what we'll find when we finally dig deep enough on Mars." "That's not the official position of the university," Keiko noted carefully. "No," Armstrong agreed. "It's not. But sometimes the truth is more important than official positions." The weight of that statement hung in the sterile air of the laboratory. Antarctica had become a place where scientists confronted truths that made them uncomfortable, discoveries that challenged not just their understanding of geology and biology, but their understanding of humanity's place in the cosmos. Were we unique? Were we alone? Or were we just one example of life's incredible persistence in a universe full of possibilities? The conspiracy theories were inevitable. A continent so remote, so mysterious, so jealously guarded by international treaty was bound to attract speculation about what was really happening there. The internet buzzed with theories. Secret Nazi bases established during World War II, complete with underground bunkers and experimental aircraft. Crashed alien spacecraft, their technology being reverse-engineered by shadow governments. The lost city of Atlantis, frozen beneath the ice, waiting to be uncovered. Ancient pyramids, mysterious magnetic anomalies, portals to other dimensions. Most of it was nonsense, the product of overactive imaginations and too much time spent on conspiracy forums. But some of it stemmed from genuine mysteries, questions that scientists couldn't answer, anomalies that didn't fit neat explanations. Tom Harrington had been a helicopter pilot for the U.S. Antarctic program for 7 years. He had flown hundreds of missions across the continent, transporting scientists and supplies to remote research stations. On a cold June evening, sharing a beer with a fellow pilot in the rec room at McMurdo, he spoke about something he'd seen that he couldn't explain. "It was during a supply run to the Amundsen Scott station at the South Pole," he said, his voice low. "We were about 50 kilometers out when I saw something on the ice. A perfect geometric shape, like a square or rectangle, darker than the surrounding snow. I circled back to get a better look, but when I came around again, it was gone. Just gone." His friend snorted. "Probably just shadows, Tom. The light plays tricks down here." "That's what I told myself. But I've been flying in Antarctica for 7 years, man. I know what shadows look like. This was different. It was solid, physical, and then it wasn't there anymore." "Did you report it?" Tom shook his head. "And say what? That I saw something weird on the ice that disappeared? They'd think I was losing it, suffering from isolation psychosis or something. But I know what I saw." Stories like Tom's circulated among the Antarctic community, whispered in rec rooms and shared over satellite phones. Most were dismissed, rationalized away as the effects of extreme isolation, sensory deprivation, or the psychological strain of living in one of Earth's most hostile environments. But they persisted, these stories, adding to the aura of mystery that surrounded the frozen continent. The truth, as it turned out, was stranger than most conspiracy theories, but in a different way than the conspiracists imagined. Lake Vostok was the real mystery, the real discovery that changed everything. Imagine a body of water the size of Lake Ontario, hidden beneath 4 kilometers of solid ice, sealed off from the rest of the world for 20 million years. The lake's existence had been suspected since the 1970s, when radio echo sounding revealed a flat surface beneath the ice that could only be liquid water. But it wasn't until the 1990s that scientists confirmed its existence and began to understand its staggering implications. The water in Lake Vostok is under immense pressure from the weight of the ice above it, kept liquid despite temperatures that would normally freeze it solid. It's a completely isolated ecosystem, if an ecosystem exists there at all, cut off from solar energy, from atmospheric oxygen, from the cycling of nutrients that characterizes every other body of water on Earth. If life exists in Lake Vostok, it would have to be life unlike anything else on the planet, evolved in complete darkness and isolation for longer than humanity has existed. Dr. Sarah Chen's team had been drilling toward the lake for 3 years when they finally broke through. The international scientific community had watched with bated breath, debates raging about contamination protocols, about whether humans had the right to breach this ancient sanctuary, about what they might unleash by puncturing the ice. The day after the camera went black, Sarah sat in the drilling station's conference room, surrounded by her team and several bureaucrats who had flown in from the National Science Foundation. The mood was tense, expectant. "Tell us exactly what you saw," demanded Dr. Gerald Thompson, the NSF's Antarctic Programs Director. Sarah pulled up the footage on her laptop, playing it frame by frame. "Here," she said, pausing on a grainy image. "This is at 3.9 kilometers depth, just as we entered the lake water. You can see the sediment from the drilling, and there, that shadow." Everyone leaned in. The shadow was indistinct, but it had shape, structure. It wasn't a rock. It wasn't debris from the drill. It moved with purpose, with direction. "It could be a gas bubble," offered one of the bureaucrats, clearly hoping for an easy explanation. "Gas bubbles don't move horizontally," Sarah countered. "They rise." This moved laterally across the camera's field of view, then disappeared. And then the camera malfunctioned. Malfunctioned or was damaged? Sarah met Thompson's gaze steadily. "When we retrieved the camera, there were marks on the housing, scratches, deep ones, like something had tried to grip it." The room fell silent. Outside, the Antarctic wind howled, rattling the station's walls. "We need to go back down," Sarah said quietly. "We need to know what's in that lake." But knowing came with costs. The NSF immediately classified the footage, citing concerns about contamination protocols and international treaty violations. Sarah's team was forbidden from discussing what they'd seen, threatened with career-ending consequences if they violated the non-disclosure agreements they were forced to sign. The drilling project was suspended indefinitely, pending further review. Sarah returned to her quarters that night, feeling a mixture of frustration and awe. They had touched something profound, glimpsed something that challenged every assumption about life's limitations. And now they were being told to forget it, to pretend it hadn't happened, to let the mystery remain buried beneath 4 kilometers of ice. She stared out her window at the endless white landscape, the darkness broken only by the distant lights of other research buildings. Somewhere out there, beneath the ice, Lake Vostok waited with its secrets, and Sarah Chen knew, with absolute certainty, that she would spend the rest of her life trying to get back to it. Antarctica had other secrets too. Hundreds of subglacial lakes discovered by radar and satellite imaging. Some were small, barely ponds. Others were massive, interconnected systems of liquid water flowing beneath the ice, creating a hidden hydrological network that scientists were only beginning to map. The implications were staggering. If these lakes harbored life, if microorganisms could survive in such extreme isolation, then the definition of habitable environments needed to be completely rewritten. And it wasn't just lakes. Ground-penetrating radar had revealed vast subglacial mountain ranges, canyons deeper than the Grand Canyon, valleys that would rival any on Earth's surface if the ice were removed. Antarctica beneath the ice was a complete, complex landscape, a hidden world that no human had ever seen and might never see if the ice persisted. But the ice was changing. Climate change was reaching even Antarctica, the planet's most remote and insulated environment. Temperatures were rising, slowly but measurably. Ice shelves that had been stable for thousands of years were beginning to crack and calve off into the ocean. The Antarctic Peninsula had warmed by 3 degrees Celsius over the past 50 years, one of the fastest warming rates on Earth. Dr. Maria Santos stood on the edge of the Larsen sea ice shelf, watching as another massive chunk broke away with a sound like thunder. The iceberg that calved off was the size of a small country, containing enough fresh water to supply every human on Earth for years. It drifted away into the Southern Ocean, where it would slowly melt, contributing to sea level rise, diluting the ocean's salinity, altering currents that had flowed unchanged for millennia. "We're losing the archive," she said to her research partner, her voice tight with emotion. "Every layer of ice contains information about Earth's climate history, going back hundreds of thousands of years. We can read it like a book, see exactly what the atmosphere was like, what the temperature was, when volcanic eruptions happened, when asteroids hit. It's all recorded in the ice, and we're losing it." Her partner, a glaciologist named Robert Kim, nodded grimly. "At current rates, some of these ice shelves could be gone within our lifetimes. And once they're gone, that information is gone forever. We can't get it back." "It's not just about losing data," Maria continued, her frustration evident. "It's about losing the keys to understanding our future. If we want to know what happens when CO2 levels reach certain thresholds, we look at the ice cores and see what happened last time CO2 was that high. If we want to know how quickly ice sheets can collapse, we study the evidence preserved in the ice. This continent is a crystal ball, and we're letting it melt before we've finished reading it." The urgency was palpable among the scientific community. Teams were drilling faster, cataloging more, racing against time and changing climate to extract as much information as possible before it was too late. Core samples were being taken from deeper and deeper, reaching ice that formed before modern humans existed, before agriculture, before civilization. Each core was like a time capsule, holding tiny air bubbles that contained the actual atmosphere from hundreds of thousands of years ago. Dr. Yuki Nakamura held one such core in the analysis room, her eyes wide with wonder. "This ice is 800,000 years old," she whispered to her assistant. "When this snow fell, there were no cities, no nations, no written language anywhere on Earth. Our ancestors were still learning to make fire consistently, and here it is, preserved perfectly, waiting to tell us its story." The analysis would take months, but preliminary results were already showing patterns that made climate scientists deeply concerned. The ice cores showed that Earth's climate had been remarkably stable for the past 10,000 years, the entire span of human civilization. But before that, the climate had been chaotic, swinging wildly between extremes. And the current warming trend was pushing Earth's climate system back toward that instability. "We're conducting an experiment," Yuki explained during a video conference with policymakers back in Tokyo. "We're pumping greenhouse gases into the atmosphere at rates never seen in the geological record, at least not in the past few million years. And we're doing it without knowing what the tipping points are, where the point of no return might be. Antarctica is trying to tell us what happens next, but we're not listening." But beyond the climate data, beyond the scientific measurements and ice core analyses, Antarctica held mysteries that defied quantification. The continent's interior remained largely unexplored, too remote, too dangerous, too expensive to reach. Satellite imagery showed strange features, anomalies in the ice that couldn't be easily explained. Some were probably just natural formations, tricks of light and shadow. But others suggested something more, something buried, something waiting. In a small office at the British Antarctic Survey headquarters in Cambridge, Dr. Harold Bennett studied satellite radar images of the Gomburtsev mountain range, a subglacial mountain system in the heart of East Antarctica. The mountains were completely buried under ice, invisible from the surface, but radar had revealed their existence and their strangeness. "These mountains shouldn't be here," he muttered, zooming in on a particularly odd formation. "The erosion patterns are all wrong. Mountains this old should be worn down, smoothed. But these are sharp, jagged, like they're young mountains. Except they're not young, they're ancient." His colleague, Dr. Patricia Edwards, looked over his shoulder. "What are you thinking?" "I'm thinking there's something about Antarctica's geology that we don't understand. Something fundamental. These mountains are preserved in a way that doesn't match any other mountain range on Earth. And there are structures here, patterns that look almost artificial." "You're not suggesting—" "I'm not suggesting anything," Harold interrupted. "I'm observing. There are features in these scans that warrant further investigation. That's all I'm saying." But the implications hung in the air nonetheless. What if Antarctica held evidence of something no one expected? Not aliens, not lost civilizations in the sci-fi sense, but something equally profound. Evidence that Earth's history was more complex than we understood, that there had been epochs and events completely unknown to modern science, preserved in ice and waiting to be discovered. The Antarctic Treaty would expire in 2048, less than 3 decades away. Already, nations were positioning themselves, making claims, establishing permanent research stations in strategic locations. The official reason was scientific research, but everyone knew the real motivation: resources. Antarctica was believed to hold vast reserves of oil, natural gas, minerals, and metals. The continent's territorial waters were rich in fish and krill. If the ice continued to melt, if Antarctica became even partially accessible, it would spark a new gold rush, a scramble for resources that could ignite international conflicts. But those who had spent time in Antarctica, who had experienced its terrible beauty and profound mysteries, worried about something else entirely. They worried that in the rush to exploit the continent, humanity would destroy the very thing that made Antarctica valuable: its pristine state, its preservation of Earth's history, its role as a natural laboratory for understanding life's limits and possibilities. Dr. Sarah Chen, now back in California after her expedition, gave a lecture to a packed auditorium at Stanford University. On the screen behind her was an image of Antarctica from space, a white continent floating in dark blue ocean, pristine and remote. Antarctica is more than a continent, she told the audience. It's a time capsule, a climate archive, a biological laboratory, and perhaps most importantly, a reminder of how much we still don't know about our own planet. We've explored less than 30% of Antarctica's surface. We've barely scratched the ice in terms of understanding what lies beneath. And every time we do scratch that surface, we find something that challenges our assumptions, that expands our understanding, that humbles us. She clicked to the next slide, showing the grainy image from Lake Vostok, the shadow that had cost her career advancement and peace of mind. This is what we saw when we breached Lake Vostok. I'm not allowed to tell you what it is. I'm not allowed to speculate about what it means. But I can tell you this: Antarctica is not done surprising us. It holds secrets that will take generations to uncover, truths that will reshape how we think about life, about Earth, about our place in the universe, and we have a choice to make. Do we preserve Antarctica as a scientific sanctuary, a place where discovery takes precedence over exploitation? Or do we treat it like every other frontier, extracting what we want until there's nothing left but regret? The auditorium was silent, the audience captivated by her intensity, her obvious conviction. I spent 6 months in Antarctica, she continued, her voice softer now. 6 months of darkness, of cold that makes your bones ache, of isolation that tests your sanity. And I would go back tomorrow. Not because it's comfortable or easy, but because it's important. Because in a world where we think we've seen everything, mapped everything, explained everything, Antarctica reminds us that mystery still exists, and that mystery is worth protecting. The applause when she finished was thunderous, but Sarah barely heard it. In her mind, she was already back in Antarctica, back at the edge of Lake Vostok, back in that moment when the camera showed something that shouldn't exist but did. And she knew, with the certainty that comes from obsession, that she would return, that humanity would return, that the pull of Antarctica's mysteries was too strong to resist. Because that's what Antarctica does. It calls to something primal in the human spirit that need to explore, to discover, to push beyond the boundaries of the known world. For 100 years, explorers had been answering that call, from Scott and Shackleton to the modern scientists drilling through kilometers of ice, searching for answers to questions we're only beginning to know how to ask. And Antarctica keeps its secrets close, revealing them slowly, reluctantly, like a sphinx that speaks only in riddles. But for those patient enough, brave enough, obsessed enough to listen, the continent offers glimpses of truths that echo across time and space. That life is more resilient than we imagine, that Earth's history is longer and stranger than our myths suggest, that the universe is full of mysteries waiting just beneath the surface. whether that surface is ice or ocean or the thin veneer of our understanding. So what are you waiting for? The mysteries of Antarctica won't solve themselves, and they won't wait forever. If this story ignited something in you, that sense of wonder, that hunger for discovery, then don't let it fade. Subscribe to this channel, hit that notification bell, because there are more mysteries to explore, more boundaries to push, more secrets waiting to be uncovered. Share this video with someone who needs their mind blown, who needs to remember that the world is still wild and strange and full of possibilities. Drop a comment telling us what you think is really beneath Antarctica's ice. And most importantly, never stop asking questions, never stop seeking answers, never stop looking at the world with the wonder it deserves. Because somewhere out there, beneath 4 kilometers of ancient ice, something is waiting to be found. And maybe, just maybe, you'll be the one to find it.